Mr. B, this is lesson 4-5. It's continuing this solving equations and now in inequality with variables on either side of the symbol. So in this case, ax plus b is less than cx plus d, and in this inequality can be solved pretty much like we solved the equation, except we have to pay attention to the sense of the inequality. So that's just one more thing to take a look at. And when you check your work, you need to check not only your answer to make sure that the boundary point is correct, but you also need to check the direction of the inequality. So we got those two things we want to do. So what's in the chapter here? We've got this for example 1, which has 3 different solutions to it. There's solution 1, solution 2, and then solution 3. There's a guided example. We'll come back to that. And then there's example number 3, followed by covering the ideas and applying the math. Example 3 is a pure word problem, interpret it. And just need to point out to you that it says when a number is less than something, it means that it's the less than symbol. If it said a number less 3, then that would be a subtraction problem where you would be subtracting 3. Is less than is the is less than symbol. So it's not too many words and a huge difference in what it means, and you'll want to pay careful attention to it as you're reading through these kinds of problems. So I'll get started with an additional example that'll be similar to example 1. Then we'll work through guided example number 2, and then I'll go through 1 or 2 examples like number 3 so we can talk about the language of the math. Alright, this is our first example for 4-5. This is similar to the problem that's in example 1 in the text. As you go through that, you'll see they're approaching it in different ways. So I will do the same. We'll do a solution 1, solution 2, and a solution 3. And here we go. So solution 1 is algebraic. So we want to create an inequality from the information in here. And the trick to doing this is to decoding what's in the problem, using the information in there to present the data. Use the units to help you understand how things might go together, because the units need to work out. So there's a lot of information, we just need to know how to pull it out. So let's take a look at the problem. The Bethel Company needs to ship items ordered by customers online. Quick delivery charges a monthly service charge of $40 a month and $5 per package. On-time delivery charges a monthly service charge of $50 per month and $4.50 per package. Initially, quick delivery will be the more economical carrier. Due to the large volume of packages needed to be shipped each month, at some point during the month, on-time delivery will become the more economical choice. When will on-time delivery become the more economical choice? So this is what we're looking for, is when will it be cheaper, or in other words, what we want to know is when will it be less than the the quick delivery charge. So what we want is we want to know when on time its charges is less than quick delivery. So this is what we're looking for. We're not looking for the equal. We want to know when it's the more economical choice, not when it's the equal choice. Equality, though, would be our boundary point. So I've written this down. Now I need to go back in here and pull out this data and see what they charge. So for quick delivery charges a monthly service fee of $40 a month and $5 per package, and is plus, and this is a rate. This is dollar per package, 5, and that's times however many packages there are. And I need I think I'll go with a big P, little p, so P packages. So this is my packages. So I've got that side for quick. Now for on time, they charge $50 plus dollars per little p for 50 times p little p. And the reason I'm putting in the units in here is because I want to see that when I do my multiplication, in fact, I'm going to work out to dollars, and p over p, that just becomes 1. It cancels out. And so the units of packages is package. The units of my variable is this little p package. Okay, so I've got an inequality. I can go ahead and set about solving this. Just like for an equality, we want to get all of the variables on one side and all the constants on the other side. My inclination here is the same as always, which is to try to get the units to be positive if I can. But I'm not sure I like how that's going to work out. So I think I'm going to go the other way. And I'm going to subtract $5 per package from both sides of this. So the 5 times P from both sides of the problem. So I'm going to do a minus. This is dollars per P, 5 times P packages. And this is a minus dollars per P, 5 times P packages. So this is just going to be 0. This will be 40. It's still less than because I subtracted, didn't multiply or divide. And this is 450 minus 5 is just going to be 50 cents, but it's still dollars per package. 0.5 times P. I want to make sure as I do this I keep those distinct. I probably should have picked a different units term. And that's plus 50. So I've got that part done, and 40 plus 0 is just 0. I'm going to subtract 50 from both sides of the equation, and 40 minus 50 is a negative $10. And 0 is just 0. This becomes 0. 50 minus 50 is 0. And so I'm left with dollars per package, 0.5 times packages. P is less than this. This is a negative, right? I hate it when I drop my negative signs, but always good to line it up so I can check. So now I've got to multiply by the reciprocal of 0.5. 0.5 is 1/2. The reciprocal of 1/2 is 2. So I'm going to multiply both sides of the equation by 2, or I could have divided both sides by 0.5. Either way is going to work. So 0.5 over 0.5 is 1. 2 times 0.5 is 1, so it's going to work out. So I've got a negative 2 times a negative dollars per package. And this has units. It's a reciprocal units because I'm getting rid of the leading term. And this is packages per dollar. So that's all going to cancel out, and that's negative, and this is 0.5 p packages is now greater than, because I'm multiplying by a negative on both sides, a negative 10 times a negative p packages times 2. Dollars will cancel out. Dollars cancels out. This package cancels out. Negative times a negative is a positive. I'm left with p packages is greater than 2 times 10 is 20, and a negative times a negative is a positive, and so I have 20 packages. So I know that when it will be the more economical choice now is when we have greater than 20 packages for the shipping requirements. Right, this is solution 2, our second solution for this first example. In this case, I've got a couple of equations I'm going to use, and from that I'm going to build a table and use the table to compare and see what kind of results we get. And this is also a way to check and see whether the results I have are comparable to the results we got from solving the inequalities. Here we go with the with this one. I need to build my table. Need a pencil, so I'll come across to here, and then I've got my table I'm building, and here is going to be my P, my package. Right, that's my independent variable, how many packages I send. So that's P. This will be Quicks cost. This will be on times cost, because that's what this is telling me here. I got $40 plus 5 times the number package is equal to the cost for Quick, and then 50 plus 4.5 times each package is the cost for on time, and I'll fill that in. Now I know that at 0 Quick is more. I know that there's only a 50-cent difference between the two, and I also know what result I got when I ran the inequality. But just using that information, I know it's not going to be 0. I know it's not going to be 1. I'm going to try 10 because I like easy, and 10 times 5 is 50. 50 plus 40 is $90. So let's see, dollars, C dollars. Okay. And then for on time, 4.5 times 10 is 45 plus 90 is $95. And I see that indeed, as expected, on time is more expensive at 10. The other thing I could note from this is that I've cut the difference from them in half. There was a $10 difference in cost if it was at 0, if there were no packages, and you were just paying for them to provide the service when you wanted it. So that's $10. I'm now $5 difference. I've cut it in half. Makes me think that at 20, I'm probably going to find them the same. And so 5 times 20 is 100. 100 plus 40 is $140. So indeed I get that. So, and then 4.5 times 20, that equals 90. 90 and 50 is $140. So I see indeed from the table that at 20 I have a boundary where it's $140 is the cost for both of them. Now I just want to verify that indeed when I go beyond that, that on time will be less. So I'm going to use 30. And 5 times 30 is 150 plus 40 is $190. And 4.5 times 30 is 135 plus 50 is equal to $185. And indeed, I see what I expected is that at 30, on time is the lower priced option. So I've got my verification, and now I would like to head on to solution number 3. So, okay, we're going to take a look at doing the graph. We've got the information we need. We've got our equations. We have data points. Let's take a look at what our graph might look like. And in here we got our graph. We want to label the axes on this. And so this down here is our packages, right? So it's P packages. This is our money thing. So this is C dollars. My package cost, I think we could probably go by tens here because that's what we did on our table. So we'll make this where we put our first 10. I'd like to be able to have some room and see some differentiation. So I'm going to go with 10, 20, 30, because that's the data points I'm going to use. So 10, 20, 30. My starting point is 40, and I went all the way up to 190, and I've kind of got a limit here in space. So I'm going to put in a discontinuity. This says we're going to jump, and I'm going to make this bottom point 40. And then I'm just going to go up by 10, so that's 50, 60, 70, 80, 90, 100, 110, 20, 30, 40, 150, 160, 170, 180, 190, 200. So now I've got enough information and I can go find these things as I go back and look at it. So now I want to plot my points, and I want to be able to plot in the 2 data points. So let's take a look at the table again. So for quick, I had 10 and 90 as my first data point. So 10 and 90. So I was at 10, 90. I'm going to mark that one on here. And at 10 and 90, yeah, indeed, I've got that one. And I put that in red. And the other one was, let's go with the 30. So 30 and 190. 30 and 190. And so I've got my points, and I should also cross at 40, right? Because the initial cost, that's right, isn't it? For quick, yeah, it was $40. So when there are no packages, there's the basic cost of $40. So I should have a point at 40 as well. Let's go ahead and draw our line and see if things kind of fall into place here. And indeed, I've got my line. It continues on kind of forever. And this was for quick. Okay, we've got quick done. Let's go take a look at what we need to do for on time. And at on time, I was at 95 and 185 and 140. So 10, 20, okay. And then the unit where it crossed the basic line when there was 0 is at 50, right? So when we intercept this, we're at 50. So let me put a mark here at 50. I know we were at 10 and 95, and it's kind of hard to split that really well. what's going to be easy is for me to go to 140, because that I know at 20 I was at 140, and that's an intersection of grid lines, and I can see that indeed they'll cross. I'm going to go ahead and draw this. And so I've got my line, I got it crossing at 140. At 10 it should be about 95. Looks like it is. At 30 it should be 185, and it appears that that's about right. And this was the line for on time. So now I have a graphical presentation that shows me that agrees with the data that I had from my previous information. So the graph of it shows me that my intersection is at 20. That's my boundary point. When I looked at the calculations in a table, I saw that my boundary point was at 20. And when I solved for the equation, I saw that the number of packages needed to be greater than 20 in order for on time to be cheaper. So this is our first example for this. I'll go on with a couple of others after I go through the guided example with you, and we'll see what happens with those. Okay, hey, we're on to the guided example for 4-5. The first solution is to go ahead and write the inequality, excuse me. And so we're going to solve 7 minus 11x is greater than or equal to 4x plus 12. And in the first case, what are we going to do? We're going to do something to both sides of the equation in order to make it, to bring all the variables to one side and the constants to the other. And so in this case, we're going to take 11x and we're going to put 11x into each of these question marks. So it'll be 7 minus 11x plus 11x is greater than or equal to 4x plus 12 plus 11x. We added 11x to each side. We then simplify it by adding like terms. We've now got it to the form that we're used to, and now we have to get the constants on one side. So in the next case, we're going to subtract, and what we're going to subtract is we're going to subtract 12 from both sides of the equation. We will subtract 12 from each side of the equation. For this next part, we've simplified it. I got a negative 15 is greater than or equal to 15x. I'm now going to go into here, and what's going to be the result here? Well, let's go back to this part. We're going to do what? We're going to divide each side by 15. If we're going to divide each side by 15, then here we're going to end up with a negative 5 over 15. And right in here, we're going to end up with 15x, that whole thing divided by 15. Now we then simplify that, and we ended up with simplifying it to negative 1/3 is greater than or equal to x. So that's solution number one. Let's take a look now at solution number two, and we're approaching it a different way. In this case, when we write the inequality, and here we're going to subtract 4x from both sides. So instead of bringing the variables to the right, we're going to take the variables to the left. When we do that, we get 7 minus 15x is greater than or equal to 12. Then next, we will subtract the constants from both sides. We're going to subtract 7 from both sides of the equation, and we end up with a negative 15x is greater than or equal to 5 after we've simplified. We're going to divide each side by negative 15. And when we do that, we have to flip the inequality. We have to remember that we have to reverse the inequality sign. So we flipped it over here, so it's now negative 15x over negative 15 is less than or equal to 5 over negative 15 because we reversed the inequality sign. We then simplify that. Our inequality sign is still x is less than or equal to a negative 1/3. And if we look back, this is what we had over here, that x was less than or equal to, or negative 1/3 was greater than or equal to x, or x was less than or equal to negative 1/3. So we've got the same thing. We check the inequality. Remember, it takes 2 different steps to make that happen. And we get negative 1/3 is our boundary point. So we want to see, does x equal negative 1/3 work to make this true? So we put negative 1/3 into here. So 7 minus 11 times a negative 1/3 is greater than or equal to, in this case we want equal to 4 times a negative 1/3. And we can indeed see that that's true. And then we want to try a number that satisfies the inequality that x is less than negative 1/3 and test it and see if it makes the original inequality true. So let's go ahead and try something. How about negative 1, because it's fairly simple, and does it work? Is it true that 7 plus 11 is greater than or equal to a negative 4 plus 12? And indeed that's a true statement. So we've done our 2 steps for our check. Now looking back a little bit, there's the question for you. My preference is to kind of go positive, when I do this, but it doesn't really matter. So I would have probably gone for solution 1. We tried solution 2. The question you want to ask yourself is, which do you prefer? Which method do you like better? What makes most sense to you? That's what you should be using. You don't necessarily need to slavishly follow what I'm doing when you go through this kind of thing. That's it for guided example. I've got a couple more examples to go through. I know this is going kind of long. I've got another 3 examples that might help you. Stay with me to take a look. Come back to it if you need help. Your assignment again is covering the ideas and applying the math. Okay, guided example, extra example 2 for 4-5. We've got an inequality. 8 minus 6x is less than or equal to negative 4x plus 12. We're going to go ahead and solve that. I'm going to work to create the positive coefficient of x. So 8 minus 6x plus 6x is less than or equal to negative 4x plus 6x plus 12. Now this is kind of the path I often take. You don't have to do this. You could go the other way, and I'll show you that in just a second. So this is going to give me 8 is less than or equal to 2x plus 12. Now I subtract 12 from both sides. So negative 12 plus 8 is less than or equal to 2x plus 12 minus 12. That's going to be 0. 2x is greater than or equal to negative 12 plus 8 be a negative 4. I'm going to divide this by 2 or multiply by the reciprocal. So I'm going to multiply by 1/2 times a negative 4 is less than or equal to 2x times 1/2. So this is negative 4 divided by 2. 2 goes into 4, negative 4, and negative 2 times is less than or equal to 2 goes into 2, 1x. This is my answer. Does it check? A negative 2 times 6 is 12. 12 plus 8 is 20. So I got 20 is less than or equal to a negative 4 times a negative 2 is 8. 8 plus 12 is 20. So it checks for my equality. So that works as my boundary point. Does it check for something where x is greater than that? Well, you know what's greater than negative 2? 0. So this was for x equals negative 2. for x equals 0, what do we get? We get that 8 is less than 12. And indeed, 8 is less than or equal to 12. So that checks as well. I've got my 2 checks for this example. Now let's take a look at it going the other direction here, shall we? So we'll get rid of this. We'll come into here and rewrite our equation. We had 8 minus 6x is less than or equal to a negative 4x plus 12. I'm going to go the other way with the variable, and so I'm going to add 4x to both sides. So I've got 8 minus 6x plus 4x is less than or equal to 4x minus 4x plus 12. That's going to be 0, so I'm less than or equal to 12, and that's 8 minus 2x. Now I'm going to go ahead and subtract 8x from both sides of the equation. I've got a negative 2x is less than or equal to 4. I multiply by the reciprocal or divide by a negative 2. Negative times a negative is a positive. 2 over 2 is 1. X is less than or equal to negative 1/2. 2 goes into 4 2 times. Times a negative 1 is negative 2. This is our solution. So your choice in which way you want to go with these kind of things. I think you look at it, make a decision, try to pick the path that you think is going to work best for you. Okay, I've got one more example for you. This is our third example for 4-5. And this is a word problem that really you want to pay attention to what it says, because boy, a key word here or there can change everything. 12 more than 8 times a number, n, is less than 4 times the number. This is still referring back to n. Find the number. Find out what n is. So the key here is finding what kind of inequality or equality, or what are we looking to find out, and is less than, right here, is what is key for it. Something is less than something else. So we want to know what that means. And so 12 more than 8 times a number. 12 more is 12 in addition to. And the number is n, so 8 times a number, 8 times n, plus 12 more is less than 4 times the number, that's 4n, and that's it. Okay, so now we want to find out what n is, and we've got to do our manipulation to figure that out. So first we'll subtract 8n from both sides. We get 8n minus 8n is just 0, so 12 is less than 4n minus 8n is a negative 4n. Now I need to multiply by a negative sign, so I'm going to flip my inequality just because I said that. So negative 1/4 times 12 is greater than a negative 4n times a negative 1/4. A negative times a negative is a positive, and 4 goes into 4 one time, so I'm left with n. And a negative 1/4, well, 4 goes into 12 3 times, a negative times a positive is a negative, and I get indeed that my value is that a negative 3 is greater than n. So here's my solution to number 3. Be careful as you read through these, decode it, make sure you've got it right and that it makes sense when you write your problem. Good luck on doing the work, covering the ideas, applying the math. Best of luck on the mastery quiz. See you in class.